Hello, everyone. Welcome to the seventh episode of optimization for FPL with Python. If you are watching from video on demand, you could have seen Trad live. And so before we go into business, I will, of course, talk about my mysterious guest, which is Trad, if you couldn't get the hint.
Here
and
I am. Yeah, it's me. Yep.
and
Yeah, I
as
guess
you,
I'll introduce myself.
yeah, sure, go ahead.
My name's my real name is not Fancy Football Trout, as you all know me. It's actually James. I don't live underwater, so sorry to disappoint you. I've kind of catfished you there a bit, which is a pun, I guess. But yeah, no, it's great to be here, and thanks Talp for inviting me. I'm sure it's gonna be a lot of fun, and I'm ready to get going.
hmm And yeah, before I start, I will ask you a few questions about how you started playing FPL. Yeah, let's start with that one.
Yeah, so I mean, I haven't been playing FPL for as long as most of the FPL analysts have. It seems like. I mean, I played casually for years and years, but always with game week, always with overall ranks in like the 2 millions. I guess I got serious about it in the 1920 season, where I started. I got a subscription to Fantasy Football Scout and all the other stuff, but I was still playing a pretty regular game. I was still using the small sample size, terrible stats that I'm lucky to say that we don't really use anymore. And I guess I only really got into the good analytical side of fantasy football probably in the second half of the 1920 season when I found Twitter and I
hmm
started talking to other people and learning so much stuff. Um, and so yeah, it's been less than 2 years, probably about a year and a half since I've been kind of deep into fantasy football analytics.
I see. And you talked about the small sample sizes. Like, how small are we talking about here?
Oh God, I don't even want to tell you. It's you probably have to. Everyone will log off the stream if I tell you. I mean, I was probably using single game week sample sizes some of the time. It was awful. I look back on it in great shame.
I know you have been also like interested in the optimization side of things in
Yeah,
terms of the analytics of FPL. So how far have you gotten?
Yeah, well, I mean, again, the optimization, it feels like I've been a member of the fantasy football optimization community so much longer than I have. It's
Mm-hmm.
really only been about a year since we started regularly talking on Twitter. And I mean, you introduced me to it. I thought kind of vaguely about it before, and I maintained my own expected value model in the 1920 season, and I ran single game week optimizations on it. But you were the first person who made me realize that actually doing multi-period optimization in fantasy football is totally possible with just normal hardware, and actually it's really, really useful. And
Mm-hmm.
I think you can gain a lot of advantage from it. So I think that I started building a linear optimizer for fantasy football back when you put those original Excel tutorials out.
Mm-hmm.
Um, and yeah, it's kind of all gone on from there. I always watch the tutorials on your YouTube site, and I'm always trying to think of new features to apply to my model, which can improve the flexibility of what I've got and can make the optimal plans even more optimal. And just I'm really interested in building a model that plays in a way that a good human player plays like. So incorporating all of these concepts like uncertainty that don't really come natural to you going for a purely analytical approach.
Yeah. I think,
Hmm.
yeah, you're right. So, especially regarding the multi-period optimization part, because most of the time when we think about optimization in FPL, the first thing we focus on is just, the next game week, because that's the only decision we are trying to give. And then
Yeah,
if you don't about the future transfers at all, like you can just get the summation of the expected points and try to optimize that one. Um,
yeah, absolutely. Yeah, there's a real. I mean, the balance between planning long term and planning short term is such an intuitive thing, and I find trying to put numbers on that balance really, really interesting. And also, it's an intuitive thing is the cost of a free transfer. Like you might, it might seem obvious that free transfer doesn't cost anything, but there is an inherent cost to every free transfer that you don't save. And I think that putting a number on that free transfer cost is a really, really interesting project and something that I'm interested in using my solver to investigate this season.
Yeah, same. Yeah, I was thinking about it because for the reoptimization competition, I
Yeah,
collected a few values, but obviously even that free transfer value is not probably fixed. I mean, I use a fixed
yeah. I mean,
value.
the thing with that is that I think, am I right in saying that that was only for the next week, right? That was like
Um,
the kind of the value that you get from rolling the free transfer, or was it more of a long-term thing
I
where
actually, I
it
think, yeah,
incentivizes?
I used it as a long-term thing. Like I added a free transfer value for the upcoming weeks as well. But I
Oh,
applied the
cool.
DK. Yeah,
Yeah,
I
yeah,
don't
yeah,
know
yeah.
if it changed things a
That's
little bit.
exactly the way that I like to do it. So that's cool. I didn't even realize. Nice.
Mm-hmm. And I'm glad I was sharing my model on like Twitter because I remember like not applying any DK at all. And then you
Oh
were the first
yeah,
one to
yeah.
talk about those things. Like I think review has DK already, but I didn't have in my
Yeah, I
model.
think at that point review already had decay, which is probably, I mean, that might be the first time I came across it, even though there's obviously an intuitive sense of time decay that probably everyone has.
Yeah.
Yeah, yeah. I think it's
Yeah.
yeah, such a useful concept to
Mm-hmm.
the linear optimization.
Mm-hmm. And my next question is, you're a Liverpool fan, right?
Yeah, I am. Yeah, I don't share my allegiance too much on FPL Twitter because I mean it's crazy how scrutinized I think that your supporter biases can get you. I mean, the accounts like Simon with his extreme lead support. I respect it, but I don't want to go too far with it. So I tend to keep it under the hood,
Okay.
uh,
Okay.
if you know what I mean.
Okay.
And you're a Liverpool fan as well, am I right?
Yeah, that's true. Like, even so, I think I started following Liverpool back in 2005 after the Champions League final, which was in
Oh yeah.
Istanbul. I couldn't have
Oh,
a
of
chance
course,
to
I was in
watch it.
Turkey. Yeah, yeah, yeah.
Yeah.
That makes perfect sense.
Um. Okay. So let me then start discussing the noise in EV before you start sharing your stuff. Let me go back to my
Yeah,
webcam. Um.
great.
Guys are able to get you on screen as well. Yeah, you will get me on screen. And even before that, I will just share my window a little bit. Uh, and let me see. So today we will talk about like noise in expected value and also sensitivity analysis, as I promised. So this is the introduction from a paper called Sensitivity Analysis in Optimization and Reliability Problems. So this paper deals with, as it says, reliability problems. So it's a little bit different, but I thought the introduction fits perfectly. So I will just go over the parts I highlighted here. The first one says sensitivity analysis discusses how and how much changes in the parameters of an optimization problem modify the optimal objective function value and the point where the optimum is attained. So this is critical because when we are talking about optimization for FPL, obviously we are trying to optimize over expected value or projected points, in other words, like using the models that we have. Like in my case, I use the reviews projected values and I try to optimize it. But the problem is, after every game or like every day, I think it's every day, at least every day. So those values change, and then when you solve the problem the second time, you get a different optimal solution. And the nature of the like optimization is interesting because we always try to get the minimal gains by transferring a player that no one else does, because that's what optimization is telling you based on the data. But data itself is not always fixed, right? Because as I said, like daily, the values are changing. From this introduction, it says, today it is not enough to give users the solution to their problems. That's correct, because when I give you the optimal solution, you might be wondering, yeah, but what if expected values change tomorrow? So then it says, in addition, they require knowledge of how these solutions depend on data and or assumptions. And then goes with sensitivity analysis allows the analyst to assess the effects of changes in the data values, to detect outliers or wrong data, to define testing strategies, to increase reliability, to optimize resources, reduce costs, etc. So this is what we will talk today. So we will talk about sensitivity analysis, and just know that there's not only one way to do this, so you can do it in multiple ways. But the most natural way I could find was just checking the expected values and how they changed in past, and then adding a random noise, and then re-optimizing like again and again. So let me go back here. Okay, I'm already sharing you, and I will click on your screen now. Okay.
There I am.
You can go ahead, James. Like, I think you will talk about EV uncertainty to us.
Yeah, that is the plan. So yeah, I mean, what I'm going to be presenting here isn't anything particularly rigorous. It's more to investigate a sort of a ballpark figure for how much we can expect EV to change over time. And for this study, obviously, I've used FPLReview EV just because it's what we all use on the optimization, and that means that, I mean, it's important to note, I think, for all of this, that FPLReview EV, the amount by which it's generated has changed quite a lot over the last season, which is the sample that I'm going to be looking at the moment. So it's worth keeping in mind that, yeah, the manner of the change also might not have stayed exactly the same. But yeah, the idea of this isn't to get any kind of rigorous results. It's just to look at a general trend that we can use later on. So first of all, okay, can you see this? Can you see this plot here?
Yes.
Yes, you can. Brilliant. So this is just an outline of the sample that I'm using, which is, each sample is basically a pair of values. It's the EV predicted in a previous game week compared to the EV, or the expected value, in the actual game week, the pre-deadline EV. So for example, when the values are down here at like minus 0.2, that means that the amount of EV has gone down by about 20%. And also it's worth mentioning that I've adjusted these linearly by the amount of X-mins as well. So assuming that they've got the same amount of X-mins, these ones down here have decreased by about 20%, whereas these ones have increased by about 20%, and these ones in the middle have stayed the same. So the first thing you might notice about this is that actually it's bimodal, which is, I mean, that really shocked me when I first looked at it. But once you could start thinking about it, the reason why it's bimodal is actually pretty obvious, which is that last year we had a lot of game weeks where we had unexpected double game weeks, which, you know, we found out about within the kind of the 7 game week planning horizon. And yeah, I mean, actually, the magnitude of this clump is really quite large. It puts it into perspective just how many major assets got unexpected and unplanned double game weeks.
It's really interesting.
Yeah, I think is really interesting.
So in this case, I have a question. So is the that second island over there, is the average around 0.5-ish? A little bit higher, probably.
The reason why it's half as much as what you'd expect it to be, because you'd expect it to be +1, is because the X-mins are still 90 rather than 180.
Okay.
So if that makes sense. So actually, the X-mins, sure, I've multiplied it by, are still half of what they should be. So yeah, I mean, but in all of this analysis, I've obviously filtered those values out because we don't really want to include them. Assuming, of course, that we're not going to have a whole bunch of unexpected double game weeks this season. I mean, fingers crossed that this one's more normal than the last one.
But it's great to have this like normal distribution shape. Yeah.
Yeah, it's good to see. Yeah, it's kind of what you'd expect. and it's always nice to get what you expect when you do this kind of analysis. So on the left-hand side here, we've got a strip plot of, again, the amount that we see EV changing by in different bins of X-mins. So first of all, there's this one, which is players with 0 to 60 X-mins. And one thing you'll notice straight away is that almost exclusively in this sample, the actual amount of EV is more than their predicted amount of EV. And the reason for this is because our sample is biased, right? Let's say that you've got a high EO player and you're looking at their prediction, they've got low X-mins, and you're looking at their prediction several game weeks from now. Several game weeks from now, they're only going to be still a high EO player if those predictions have stayed the same or got better. The fact is that if you have an X-mins risk and their X-mins drop off a cliff, then they're no longer going to have the ownership required to be included in their sample, which is a bit unfortunate because it makes this whole analysis a bit biased. But it is what it is. There's always a trade-off with this kind of thing between getting actually high-quality data and getting an unbiased sample, which is unfortunate. But as you can see, I mean, we do see an important trend, which is that for higher X-mins, the underlying amount of noise is the amount of noise for future game week predictions is lower, which again is what we'd expect to see because because players with 80 to 90 X-mins are more likely to retain the number of X-mins they have several game weeks down the line. And the same is true, but slightly less true for 70 to 80 game weeks, and even less true for 60 to 70 game weeks, 60 to 70 X-mins rather, where it's quite spread out. And again, on the right-hand side, I've just included this so you can see what I'm talking about. In the sample, almost all of the assets that have 40 to 60 X-mins saw an increase in their X-mins over the sample period, which is again, that's the source of all of the bias that we're seeing here. In reality, you'd expect all of these distributions to be centered around 0.
Yeah.
Or you'd hope so.
Yep.
Okay, so moving on. This is the formula that we're going to be using to talk about uncertainty and noise in EV projections today, which is it's a bit of a simplification, but I think that's probably a good thing to start with. So first of all, we've got EV, which is the amount of points that obviously is projected for the future game week. This is the number of X-mins that they've got in the future game week. And then we've got two manual parameters, A and B. I've just called them A and B. You can call them whatever you want. I'm sure you've called them something different, Sertal. So as you can see, if we adjust A is probably going to be 90 or higher, because I mean it doesn't really matter, but just for the sake of consistency, you want this expression at the top to be positive. If you have a really, really high value for A, then the X-mins that you're taking this away from generally affect the expression less than you'd expect, less than otherwise. If A is 90, then if you have 90 X-mins, then this expression is just going to go to 0, and there'll be 0 noise. Whereas if there's 45 X-mins, then there'll be, the top half of this fraction will be 45. And then B is a parameter that indicates the amount of general noise that we're working with. The higher B is, then the lower noise there is in general with this experiment. And the higher, obviously if B is a very low value, then we're going to have lots of noise, and we're going to get hopefully quite a wide spread of solutions. So then I tried to just fit this formula to that which gave the best results in the data in terms of the amount of absolute noise, and the values that it came up with were 91.6 for A and 134.1 for B. But again, I don't think these are that important. They're quite sensitive to the sample that we're using, and I would just recommend playing around with them to see what feels right for you. So then anyway, what we actually have here, it will let me go back to the previous slide. I don't know if it will, so let me try and go back here. There we go. So that formula that we were just on is really just a linear product, or a linear formula of X-mins. So I think a logical next step is to build an actual linear model that takes X-mins as well as other things into account. And this comes up with some interesting results if we do this. The first thing that we see is, as we would expect, the coefficient for X-mins is negative, which means that the higher the X-mins are, the lower the general amount of uncertainty is. The coefficient for points is positive, so the higher the points are, the more uncertainty there is. I've also introduced a parameter called the difference in game weeks, which is the approximate cumulative amount of extra uncertainty that you'd expect to see each game week. And again, these are normed, so that's equivalent to about 1% extra noise per game week. And then also I've got the positions. T.F is for forwards, T.G is goalkeepers, and T.M is midfielders, and then defenders are part of the background sample. And as you can see, the coefficients for all of those are negative, which means, interestingly, in the sample, defenders had more unexpected noise than players in other positions. So then, yeah, this is quite a nice way, but it's a bit ugly and a bit complicated. So anyway, this is the last slide, which is where you might want to take it, where I'll probably take it, but didn't have enough time to take it this week, which is using more. It's like using the same parameters as I did in that linear model I just showed you, but with a concept of statistical distribution, so you can think in a kind of Bayesian way about it. So on the graph on the left, or the plot on the left, I've plotted the amount of EV noise for each amount of game weeks into the future. Again, minutes adjusted and normed. So for one game week into the future, you can see the distribution is a bit narrower. They all look kind of normal, but this one's much narrower than the others. And then as you go further and further into the future planning, the uncertainty spreads out, so it becomes increasingly more and more uncertain, which again is totally what you'd expect. And then on the right-hand side, we see how predicted X-mins turn into X-mins. So again, the problem with this is that in all of the samples, you're more likely to see an increase in the amount of X-mins than you are a decrease, because you've got to have EO on both ends. So it's not really worth paying attention to the 0 to 60 and 60 to 70 ones. But on the other hand, the 90 X-mins ones I think are quite interesting, or the 80 to 90 X-mins ones. You can kind of see the general shape of where it ends up, which I think is quite interesting.
Yeah, that's interesting.
Yeah, and then using these two plots in conjunction, let's say you're looking at an asset with 85 X-mins 4 game weeks into the future. You can theoretically multiply these two distributions to get a general distribution for the amount of uncertainty that you'd expect to see in their future projections. And yeah, that's about it. I mean, that's where I stopped looking. I will probably look at this in the future, because it looks like a pretty fun thing to work out, and obviously it would be slightly more applicable than what we're doing today. But what we're doing today, yeah, it should provide a much simpler basis than all of this nonsense.
Okay. Yeah. Well.
So yeah,
Awesome.
anyway, that's about it.
And we also talked about with you when we were chatting on Twitter about probably the number of days until the game week deadline could be also a factor, because in some of these cases.
This is an interesting thing with time decay in general. It's difficult to balance. To what extent time decay exists because of the amount of football that happens in between the game weeks, or to what extent it exists due to the amount of days that occur in between the deadlines. In reality, it's probably a bit of both. But again, that's something that I've never looked at, and would be something that's really, really interesting to look at and to include in this kind of uncertainty analysis.
Yeah, that's true. But this is great. So at least it also agrees with our initial thinking, because obviously we are thinking of having more noise as you go into the future, and it's nice that the data agrees with us.
Yeah. I think this was quite a satisfying little look into the numbers. Like, yeah. It kind of came out, apart from the unfortunate sample bias, it came out exactly how I hoped it would. So
if you remember from the last episode, we were talking about converting expected minutes to essentially probabilities of playing in the game. So we talked about autosub and other stuff. So if you didn't watch the last one, it's not a big deal. But so the function we will use today is the get data, where we are getting the FPL API data first, and then process data in a way that we eventually we give this pandas data frame to our solve multi-period FPL problem. Actually, I'm also zoom in a little bit. Might be too small to see. Here, let me open this function again. And also, I will also delete these comments from earlier. And also, in the last episode when we were talking about bench weights, I added this as a command so that you can see, what I was planning to do in this episode, essentially. But so this part says changes for random noise. So this is the part we will actually add noise. So again, for the sensitivity analysis, using what James presented, we will use those noise, add it to our data, and then try to solve problem over and over again. Because if you use optimization, if you just give static data, if you solve it once, whatever solution you get, you will always get the same solution, regardless of how many times you click optimize. So what we want here is using that kind of noise added to our sample, but then if we do it only once, suppose you just randomize XP a little bit and solve it once, you're still not sure because it will be optimizing it for that specific case, and you will get probably an edge solution specifically for that one. And I think in earlier streams someone suggested maybe applying this random noise based on team. So if you have players from same team, same position, like defenders, maybe they can get their XP, their noise could be together. That's a good idea actually, but we will just go relatively simple here and then
that is a good idea. I hadn't even thought of that, but it makes sense since some of the uncertainty is at a team level and a fixture level rather than just at a player level. So that's a really interesting idea.
Yeah, because essentially the EV changes because the probability of having a clean sheet probably that's the thing that's changing for defenders. So if you are more likely to get a clean sheet, you expect other defenders in the team also get a higher EV. So as you see, you can go crazy with this. You can apply this at team level, position level, and then especially if you know the distribution underneath. For defenders, I think it's only clean sheet and then maybe bonus points if they tend to get it, which is hard to predict. But again, but still, you can use in that case, for example, the clean sheet. If it is more likely to get a clean sheet for a team than yesterday, obviously XPs go higher. But then within the same team, you are people competing for the same bonus points. So it is kind of an interesting case, but I think the best thing to do would be checking the last year's state and see if we can get a noise function. So the good thing with Trout's data is as you saw, it was kind of like normal shaped, and then that's what we will use too. Here, the first one. First of all, I will import NumPy here, so we can get random data, random sample essentially. And here, RNG, random number generator. I am adding this because I want to send a seed number to function. This is obviously not required if you don't pass any value for seed. I will say this seed value is equal to none. If it is none, it will just generate a true random sample for you. But if you are interested in a specific random seed and then that specific scenario, it might make sense to give seed number to the function so you can just repeat the experiment using the same noise. This is essentially not required. You can just omit this part and then get a random sample every time you do. And that's what I do when I'm applying sensitivity analysis, but sometimes it's useful. And the second line here is essentially a list of game weeks. Remember, we were using game weeks here as a list from next game week to until the end of horizon. We didn't have it here, but then again, we need to have this game week number so we can actually add the random noise to every game week separately, because the columns are separate. And also, as I switch between James and Trout, but which one do you prefer?
I don't mind. Yeah, call me James.
Okay.
Why not?
As James mentioned, so you can also use, how many game weeks ahead I'm trying to add noise, and then use a noise based on that value. So, but let's keep things simple. So I will just say game weeks is equal to a list range from game week to minimum of 39 is just the maximum game week we will have, and then game week plus game week range. And game week range here, let me see if we are passing it here. Let me go back all the way here. So this is a standard problem. When we are solving here, we are getting data. Okay, so we will have the horizon here. So I will just add it here. So I will say horizon, the new parameter. So, also seed number. Okay, let's see. Here I will say seed is equal to seed, and then I will pass seed to here. Okay, and then horizon will come here. And then get data will get this horizon, and finally I will use horizon, and then add it here. So I will just use it this way, so if you don't pass any parameters, it will be none anyway. And here I am saying game weeks is equal to this range. And finally, what we can do now is for W in game weeks, game weeks like this.
Yeah, GW.
Yeah, I'm using game
Classic.
weeks below and then just GWS here. So remember, merge data was our pandas data frame, and the column we are trying to reach is W underscore PTS. That's the format of FPLReview data. As you can remember from here, it is game week number underscore PTS, and then we will be using this column, so it is game week number underscore xmins. So first of all, we will get points, because James showed that the noise is relative to expected points. So we will get this one first, and then times, was it 91.47?
The value that I had was 91.6.
Okay, yeah, I will use 92 here, minus, and then we will get merge data fw underscore xmins. So here, and also divided by 134. So here, for every game week, so this is a column. So this is just a pandas series. So when you get like 92 minus an entire column, it just gets the subtracts values for each of them, and then returns you the entire column. And then when you divide the static number, well, then it just does it as you predict. And then when you multiply a column by another column, it just makes piecewise product, and then you will end up with a column. And then I will multiply this with the random standard normal sample here, though. We need to give a size. Otherwise, you will generate a single number, and then you will use it for the entire column, which is not what we want. We want to generate random numbers for every row separately. So I will say size is equal to len, and this is the size of merge data. And then merge data, remember, will have as many rows as number of players in the system. we will multiply this. Well, I won't multiply this with magnitude here, but essentially the idea behind magnitude is you don't need to apply the entire the noise always 100%. You might be interested in reducing the magnitude a little bit. Sigurd was
That
here.
would be interesting to do with the same speed, actually, wouldn't it?
Yeah, that's true.
Use
Oh
the
yeah,
same
you're
speed
right.
repeatedly and
Using a lower
yeah.
magnitude. You're right. Okay, so this is the noise, but obviously after calculating the noise, we need to add it to the column itself. So I will just, since I'm a little bit lazy, I will just copy from here. So merge data points. So this is the base, right? So I will use the actual value and then add noise. So this noise, again, since we are using standard normal, could be negative too. So we could be reducing, not always increasing, but okay. So this will do the trick. So we will actually try to solve this problem without any noise first. So what I will do is, and also I think it will make sense to, it makes sense to make this operation optional, because currently the get data function is just adding random noise every time we try to solve, but it's better to have an option to turn it off. And so I will essentially, let's see, seed none, and then I will say randomized false here, and then I will pass randomized here. So actually, in the probably one of the future episodes, we will clean this a little bit, because this function is getting bigger and bigger. So it makes sense to pass an options dictionary perhaps, instead of having all these parameters listed explicitly. But I will keep it this way for now, and then here I will say.
Yeah, the way that I've written this section in my model is I've kind of split it into two separate parts. So my solver is an object which has certain attributes such as decay rate and the value of a free transfer and stuff like that. And then I've got a method within that class, which is the solve method, which takes into account the case-specific stuff like the projections and and how many free transfers you've got and stuff like that. Which I think is an interesting structure.
Yeah. I think my current model is also very similar to what you described. So I get parameters and status like separately. So I will say that, so if randomized, then do this operation. And since we are overwriting the column itself, so we don't need to do anything else. So we just have an optional thing over here. Let's see. And then we are optimizing it. I think the rest will stay the same. I think so. This is the only part we added this episode. Actually, not too much, but it's important. Here I will say. So we had actually, let's go back to the standard problem, and then I will add another function and call it solve randomized problem. So this is episode 7 edition, and then here I'll say solve multi-period. This is my team ID, and then game week 5. I have 2 free transfers, but let's keep it 1 to simplify things a little bit. And horizon is equal to 3, so that it runs faster. Higher horizon is better, obviously. Objective is regular. And then now we will add, I will keep seed to none, and then a randomized equal true. So then I will first solve standard problem and then solve the randomized problem to show you the difference. Here, instead of optimal plan regular, I will say optimal plan randomized. I think it will also print the picks and summary for us, so we will see which players are getting added, not. Okay, let's see. So here I will go under source and then run multi-period. I haven't updated the FPLReview data actually, so this data is probably from last week. Yep, it's game week 4 data. But yeah, since I'm using 5, it will only use 5, 6, 7. So hopefully we will get something nice. Oh, Calvert-Lewin might have a better projection here.
Yeah. I better get Calvert-Lewin. Oh no.
Yeah, so as you see, it is buying Torres and selling Benrahma this game week, and then selling Tony next game week, and buying Bamford, and then okay, it insists on going on. I think there was another defender transfer at the end, and let's see.
Yeah, this is probably a good time to be running this exact experiment, actually, because I think a lot of people are now dead-ending into their wildcards, which are going to be in 3 weeks' time, I believe. Yeah, game week 5, game week 6, and game week 7, and then most are wildcarding in game week 8. So there's never been a better time to run lots and lots of different optimization problems very quickly using just a 3-game week horizon.
Exactly. And as you see, the first transfer is different now. It just tells me to sell my beloved defender, Tsimikas, and then get Cancelo, and Fernandez, sell, Bruno, and finally buy Ronaldo in game week 6. Oh, it's solving 4, 5, 6, but okay, yeah, same idea. James knows game week 8 wildcard is the one. Yep. Yeah, that's how I'm solving.
Actually, I think I'm probably not going to be wildcarding game week 8. Weirdly enough,
what?
I mean, it's a really good. Yeah, I know. I just my team suits just playing through game week 8, and I think wildcarding later, as late as possible, pretty well. But I mean, game week 8 wildcard is a really, really good strategy, and I'm sure it's what most of the people in the analytics community are going to be doing.
Yeah. Well, now you got me thinking. I was so focused on using my wildcard game week 8. Yeah. Okay. Yeah. Maybe I should reconsider.
I mean, I'm leaning towards not using it, but actually, at the moment, the optimal solutions for my team seem quite similar in both ways. Like, I think my solver is recommending I do Tsimikas to James, whether or not I wildcard in game week 8. So it pushes the direction of my team is quite easy.
Okay. Yeah. So I think that was all for regarding this part. As you see, we randomized the problem a little bit, so the solution changed, but the solution still makes sense, right? Now I will show you how I added this to my own planner. So this model here is the one I use for tutorials. So I'm just trying to build this piece by piece. But I also have my own model, which has almost all of these things implemented. So let me share my screen and then share you this. So after thinking about the sensitivity analysis a little bit, also the noise, actually we talked this topic with James a little bit earlier than this, maybe a month ago. And I was using his idea. I added the sensitivity analysis pretty recently. So what this does is it just takes. So the first number is how many random scenario you are trying to generate. How many times you want to solve this problem. And then the second one is how many solutions you are trying to generate. So in terms of how many solutions, you might remember from episode 4, I believe we talked about generating alternative solutions. What I'm doing is I'm solving the problem, finding the optimal solution, and then adding a cut so that solution will never appear. And then that cut could be based on which transfers you have. Like in this case, I have this option here. As you see, I have this iteration option, and then I have different ways of differentiating solutions. The first one is transfer difference, meaning that if a solution gives me, transfer this and this guy, I say, okay, eliminate at least one of them in the next solution. So they cannot be transferred in together. That's the cut I'm adding, but there are multiple ways to do it. But anyway, so when I run the sensitivity analysis, I will get top 3 solutions for every random scenario, which is
which actually makes sense because you don't only want the top scenario all the time, because you don't know if the second best is close enough. And then when we do it, so these are the solutions. So I actually ran 20, should be 20 random scenario, and I got top 3 solutions. But obviously, if I'm really not sure, I can use a really high value like 40 replications and then maybe top 5 solutions. So here, the solution that appeared the most is this one: sell Fernandez and Obafemi and then buy Torres and Lukaku. And then the second best solution is selling Tony and Antonio and getting Bamford and Jimenez. And as you see, this solution appeared on the 3 of the entire 20 scenarios. And among those 3, it was the best solution. Actually, I'm not sure if it is 10 or, yeah, should be 20. And on the other hand, this solution appeared 8 times, and 4 times as the best solution, 3 times as the second best, and 1 time as the third best solution. So, and using these, I can also see, what's the, standard deviation. Obviously, you need more samples to make sure, this score is reliable. And you might be wondering, what happens if you don't add any randomization or anything. So these top 3 solutions, let me go back here. Okay, yeah. So these 3 solutions over here are the one without using any noise. So these are the solutions that I have solved with no future transfer. So it tells me to sell Tsimikas Antonio and get Matip and Bamford, which is this solution. So as you see, in this randomized test, it is inferior compared to some others. This solution appeared more, it was in the top 3 more often than this solution is. So this is kind of a really good case because, again, so you can compare these scenarios and use some extra information about whether you want to buy, let's say, Bamford or not, depending on whether he will play next game week or not. But this gives you a better idea instead of, solving it once and then seeing only this as the best option. Because as you see, as we randomize things a little bit, we see other solutions too. And then the question is, how many scenarios did you run? So for this one, I ran only 20 scenarios, but I usually try to do it at least 40 because of the central limit theorem. But yeah, it depends on how many. Yeah. It depends on how much time I have. And also, let me open another tab here. So we have only a few minutes left, I think. But I will run a scenario here, so we can go together. So this is my current team, and as you see, Antonio is obviously not playing. And then looks like, do you use antithetic sampling across the 40 samples or other variance reduction techniques? I just add the random noise variance reduction techniques. I don't apply anything else actually, but in the solver I have this random magnitude. Even if I am trying to randomize things, I also enter a magnitude which is 100% means I am applying noise as is, as we just shown before. So here, since I was thinking of using my wildcard game week 8, so I will just solve for 3 game weeks, and then here I will probably won't change anything for now. I'll just try to solve this directly and then talk to you about my plans. And from the sensitivity analysis, so I will also try to apply this Fernandez Obafemi. So I will say Fernandez, and so this is, in this case, I am trying to force it, and then by Torres and Lukaku.
This is so beautiful. I just wanted to say this.
Thank you.
That you've got is just amazing. I'm so jealous of having to type, having to type all this stuff into my code, and you can just put it in an amazing web interface.
Yeah. It is, because
definitely.
I was also using, just codes, and I was running my Python and then getting the CSV file, checking it. And then after a while, I
Yeah.
said maybe I should just build an interface so I can see more of the stuff.
Yeah, as far as I mean, I've only gone as far as printing out nice-looking strings that have the optimal solution arranged in a kind of a nice-looking order. But this is this is a whole different level.
Yeah.
It's amazing.
Was that a field called minimum hunt length? Yeah, there is a field called here, minimum hunt length, because sometimes optimization buys a player only for a single game week, and then yeah, people are not very happy about it. So the first solution, by the way, is the one that I didn't do any changes. Like I just solved the problem, and then it told me to get rid of Antonio and get Bamford. And then in the second one, I actually used the suggestion I got from the sensitivity analysis here, the top solution. As you see, in terms of score, this is inferior, obviously, because this is the one. So in this case, I am solving it for the exact expected points data. Then this cannot be the best solution, obviously. But as you see, it is like super close. Like the difference is 0.6%. Less than 0.6%. And so the good thing is you can actually click on it and then see, what the plan looks like. If I sell Antonio and get Bamford, and then next week it sells Tony and get, oh wow, Richarlison and then Lukaku for the game week 7.
Richarlison, wow.
That's a
Maverick.
Yeah, I was going to say.
Yeah.
And then the
Bloody hell.
second solution that we forced is Fernandez, Obafemi, get Torres and Lukaku this game week, roll free transfer following game week, and then get James instead of Alexander-Arnold because they're playing against City, right? Yeah, Liverpool is playing City.
Yeah, that's right.
And then get Tony instead of Bamford for the game week 7. So obviously these two are a little bit interesting cases, and in terms of lineup XP, as you see, it's just 0.2 points better, this one. And then the bench is also better. So you might be wondering why the score is higher on this one. So I think it's because of the free transfer, because in this case I'm rolling, so I'm having that score from having an extra free transfer. And then in terms of a budget, obviously this move leaves me with more budget because buying Lukaku will just destroy my in the bank amount. So I'm not really sure what to do, and I was just checking these values and I was discussing them with some other people. I think getting Bamford and Jimenez together is also a good idea, I guess, because they look like the popular options, and Antonio, I will get rid of Antonio.
I can imagine a bandwagon developing around both of them.
Yeah.
And obviously, I mean, is Antonio going to drop in price again before the deadline? I don't know. I haven't been following that situation too closely, but especially if you've got a weak bench, I can see that coming in really useful.
My that's true. My bench is weak. And before I close the stream, I also would like to show you something really nice I just developed today. So this ownership tab, actually, I got top 1,000 managers from FPL Research's spreadsheet. I got their IDs, and then I just I'm pulling their data and what kind of team they have, at least for the last game week. And then when I click players, then I can see what's the elite ownership and then the overall ownership and what the difference is. Obviously, some of them will get rid of Antonio here, but there are some interesting cases too. Antonio doesn't look to be dropping again.
This is lovely. When is this coming to FPL optimized?
Probably soon, because
yeah, I mean, I'm serious. This is very cool.
I wrote the code, so I should be adding it soon. With this, let me go back to my.
Thanks, FPL Spaceman, who says Antonio doesn't look to be dropping again. That's good information.
Yep.
Because I think, in my situation, if he was to drop again, I'd lose 0.1 value on him, which might be pushing me towards transferring him out to Bamford. But as it stands, I probably won't.
Yeah. Yeah, I'm still not sure. I think, I think I saw a poll on Twitter, and most people are leaning towards keeping Antonio, but well, I'm
Yeah.
not sure because FPL Twitter is just different than overall FPL players, I guess. Because not certain.
Yeah. I don't know. I think that I think it's very much team dependent, that decision, really, isn't it? How optimal that decision is. It really depends on how strong your bench is. I'm in a kind of lucky position this week where I've got Dunk first on my bench, and that's really not the end of the world if he has to come in. As it happens, I'll probably bring in James in as well. So Dunk will be first on my bench, and then Antonio third on my bench. So, yeah, I'll be in a decent enough position that I won't need to transfer him out. But I've seen lots of good teams where the need to take him out might be there.
Yeah. It was almost falling in price. Dunk.
Oh yeah, Dunk is falling in price. Yeah, I mean that's another thing that I have been considering is Dunk to James instead of Tsimikas to James.
Yeah.
And yeah, that's definitely something to consider is if Dunk is falling in price tonight or in the next couple of days.
Yep. So like in my case, since I was thinking of having the wildcard on game week 8. I know I won't be getting Jota soon. Well, for those 3 game weeks because they are playing City on game week 8. So I wasn't really sure what to do either. Yeah, because if I'm selling Tsimikas, it should have a meaning, right? Because I have too many non-playing bench players currently.
Yeah, I think selling Tsimikas is it's something that I would definitely do selling Tsimikas is something that appeals to me more as someone who isn't definitely wildcarding in game week 8 because Tsimikas is just such a long-term liability. I hate having him in my team at the moment, especially when Jota could provide such great value any moment. So
that's true.
Yeah, that's why I'm leaning towards selling Tsimikas instead of selling Dunk. Just because I'm probably not going to wildcard in game week 8.
Yep. Yeah, I should also just consider it. Yeah. Okay, so I will close the stream slowly because it's 5 p.m. now. So I would like to thank you, James, for joining me today and then showing your research.
Really enjoyed it.
It was great to have some kind of
I've
quantitative
had a great time today.
Thank you for
enjoying. I've really enjoyed being on.
I think the part we added regarding like randomized data is, as you saw, it was just only 5 lines of code, but it has it hopefully will give you a better understanding of like the decisions, because I keep saying this, but in FPL expected points are so close to each other, so solutions are only slightly different from each other. Like the best solution and then the second best solution is usually there's only a small difference in most of the cases. So hopefully sensitivity analysis will help with this. Spaceman, thank you for watching, and this was awesome. Thank you, James, again, and thank you for listening.
No, thank you very much.
And hopefully I will see you next time.